All right. So as always, our learning process is all about respect for ourselves, each other, and our world. We ask you all to show respect by using kind language and appropriate words in the chat box, as this is a program for everyone. As always, we have a moderator for the chat, and we can disable the function if that's necessary, but I don't think it will be. That said, it is okay to disagree and to share your feelings. We welcome all ideas that are founded in respect, and we invite all of you to do the same. When we have the lab on site, we encourage our learners to lead with their questions and ideas. So I'll be asking all of you plenty of questions and hope you will share your ideas and your own questions as much as possible in the chat. So let's go ahead and get started with our experiment today. Is there anybody at home who's going to be following along with our experiment? It's okay if not. Sometimes it's fun to kind of watch what people do first, and you can always check it out after the show. Maybe some of us are. That's great. Awesome. And you know, you can do some of it. You can do some and watch what I do. You can do it all with me. Whatever works for you all. But I'm really excited to get it started today because we're talking about some of my favorite stuff. We are talking about rocks today. So here are 2 rocks that I found near my house. I've got a bunch of rocks all around me that I'll show you all a little bit later. And I would love to ask you all what you know about rocks. What is a rock anyway? What do you think? What is it made out of? Where does it come from? Are all rocks the same? What do you think? Rocks are hard, for sure, Jenna. They definitely are. I know that these 2 are definitely pretty firm rocks, although I do know some rocks that are a little bit on the softer side, and we'll be talking about some of those. Oh, minerals are associated with rocks. Yeah, in fact, we might say that the definition, if you want, of a rock is that it's made out of 1 or more minerals, right? So I don't think that I have with me today anything that I know exactly what minerals are in it, but I do know that they're mixtures of minerals. So these are all rocks. So multiple minerals. Very nice. Oh, they have different colors. That's a great point. Yeah, when I look at these immediately, I see that they have different colors. That is so cool. So let's take a look. Let's take a look at these 2 for starters. Now we noted things like, oh, this is a really good addition. Rocks can be fossils. Yeah, if it's a fossil, it's made out of rocks. You're exactly right. And a fossil is cool because it started off as something else, but over time it became a rock. It got replaced with minerals. Yeah, there's different textures with rocks. So a lot of these things that you all have noted are things that geologists or rock/earth scientists note when they are classifying rocks. When they're looking at rocks and saying, I think you're this type and I think you're this type, right? So we're going to be looking at some of the different characteristics or things about rocks that can help us classify them. The first way that we can classify them is something you all already noted. We can look at their color. So I have a couple rocks here. I don't know if all of you have rocks in front of you, but if you do, can you tell me about some of the colors that you're seeing? What do you think? I know that for this one, I'm seeing some kind of like milky white color. It almost looks kind of gray. I'm seeing bits of darker brown. For this one, I'm seeing kind of sandy colors. It looks like gray and brown, right? Oh, so we see brownish, tan, black, gray, white, and red. I have this one that actually looks a little bit red. It looks like it's white and that it's red. Very nice. What else do we notice about them if we look at them visually? What do you think? Gray and red and tan. These are some really good descriptive words. I know that a lot of the rocks that we tend to find outside tend to have, earth tones, right? We tend to see a lot of like tan and white and brown and yellow, maybe some green. I have some other rocks here that maybe we'll get to look at closer in a little while that have some pretty exciting colors. And we can talk about kind of how those colors come about. But these are really good observations. Color is one of the ways that we can classify rocks. right? Another thing that we can tell with our eyes is how the rock interacts with light. So I have some light coming through here, but I've also got a flashlight. If you are doing the experiment along with me at home, you can use a lamp, you can just use any nearby light source. What we want to see is, how does light interact with this rock? Right? Does when the light comes down, does it hit the rock and bounce back? Is it very shiny? Or is it something that it kind of absorbs light? It's sort of like a piece of wood might absorb light. Also, does the light shine through the rock? Or is it not really possible to see light behind this rock? What do you think? And it's okay if you don't have any rocks with you. You can always make observations about the one that I have here. So I'm looking at this rock, and I'm going to use my flashlight to shine on it. And I'm seeing that it's not super shiny, right? So I could say that this rock does not have a lot of luster. Luster is how shiny a rock is. So this one is not super shiny, but I do have one here that has a pretty high luster. I'm going to try not to shine it in my eyes. It shines back pretty well. A nice kind of like polished quartz crystal there. And that one I would say it has a high amount of luster, lots of luster. What about our ability to see light through them? We would say the opacity, how opaque or transparent it is. Are you guys familiar with any of those words? If you know what opaque or transparent means, do you want to let me know? What about opaque? Let's start with that one. Does that sound familiar? What do you think? If it's opaque, can we see through it? What do you think? Yeah, if it's opaque, we can't see through it. So when I look, say, at this rock right here, I cannot see through it. And if I shine my flashlight, you can't see any of the light behind it. So I would say this is pretty opaque. Transparency, right? If it is transparent, that's the opposite of opaque. So if I shine the light into something that is transparent, will we be able to see the light on the other side? What do you think? Yeah, exactly. If it's transparent, we should be able to see the light come out the other side. And this is a really great comment, Alexa. Metal, like a mirror, is something that bounces back light. But rocks don't necessarily bounce back that light. A lot of times if they're metallic, if they're metal-like, they can be kind of shiny and bounce light back to us. But a lot of rocks, like this one, do not have the same luster as something like a metal might. So let's see, do we think some of our rocks are translucent or transparent? Transparent means we can see through it. Translucent means you can see a little bit through it. So my glasses are completely transparent. I can see all the way through them. If I look at my quartz crystal, I can see light shining all the way through it. I can also see all the way through it. So I would say that this is transparent. If I'm looking at something like, maybe like this piece of quartz, I can sort of see through it, but not very well. It's a little bit cloudy. But if I shine light through it, I can see the light on the other side. So this is a little transparent. So I would call it translucent. So let's see, the ones that I have, if I look at this one, in the middle, it's pretty opaque. I can't really see the light. But if I move it to the corner, you all can kind of see that the edges of it are kind of translucent. So this is a test that we can do on rocks to classify them. We can see, how does light interact with them? What kind of colors do you see? Taking the color idea a step further, you can always use a little bit of water to change, to see if it changes the way that your rock looks. I'm going to go ahead and switch my camera to my rock cam, to my experiment cam, so we can see kind of what I'm talking about. And this is a good point, Alice, right? We think that maybe most rocks that we think of are not super transparent, right? Maybe many of the rocks that we find around us don't tend to let the light through. That's a good observation. I'm going to switch my camera to my rock cam here. All right, so I've got a couple of rocks in front of me. Let's see. Oh, here's a good one over here. And I'm going to do, I'm going to see if they change if I put water on them, right? Because some rocks look different when they're wet versus when they are dry. So I have a little bit of water here, and if you have some, you're welcome to do it along with me. And I'm going to just wet part of the surface and see if that changes anything. Now I think you guys might be able to see that there's a pretty good color difference. Right now it didn't change colors completely, but we can definitely tell which spot is wet versus which spot is dry. It also, of course, changes the luster when it's wet, right? It looks a lot shinier when it is wet. This is a pretty cool example right here. I can also use this one. This is a little bit of fluorite that looks kind of dull, but if I put some water on it, it changes to be a little bit brighter. And I can do that with this one as well, right? A little bit dull, but if I get it wet, look at that, those colors are a lot bolder. And this is something that if there's someone who is ever selling rocks, a rock vendor, because lots of rocks are really cool and people like to purchase them. I myself have purchased rocks before. I've learned that it is actually not legal to sell a rock that is wet. You have to, if you're selling a rock and have a picture of it, the picture has to be of the rock when it is dry, because it is misleading if I show this nice, shiny looking, deep colored rock, but actually it's just wet. This isn't how it would look, whoops, when it was dry, right? That's how it looks dry. That's how it looks wet. Dry, wet. So there are different things that affect the color of it as well. So that's one way to classify it. What about ways to classify rocks that we can't see, or we can't see right away? Earlier we talked about how rocks have a different, some rocks are harder than others. Hardness, how hard or soft a rock is actually one of the ways that geologists classify rocks. So I've got a few of my rocks. I'll test this one and this one. And we're going to test its hardness against some different materials. There's a scale, kind of like a temperature scale, right? If the number is really high, we know it's hot. If the number is low, we know it's cold. There's a scale called the Mohs hardness scale that tells us whether or not a rock is hard or soft. So if the number is low, the rock is pretty soft. And if the number is high, the rock is pretty hard. So we're going to start with a tool that I think probably all of us have. We're going to test the hardness of this rock versus the hardness of my fingernail. So I'm starting off with just my fingernail, and I want to see, can I scratch off a piece of this rock with just my fingernail? And I'm going to switch my camera so we can see it closely. So it's sort of like a tournament. We're seeing which one will win, my fingernail or the rock. Do you guys have any hypotheses or guesses? Do you think that the rock will be harder or my fingernail will be harder? What do you think? Think the rock? Yeah, this one feels pretty hard to me, and it doesn't feel like it flakes off easily. So I bet you all are right. Let's find out. So what I'm doing, and what you can do at home if you want to, is I'm just testing to see if I can make a scratch in the surface of this rock. And I'm going pretty hard, and I can't really see any scratches in the surface made by my fingernail. Yeah, I think you all are right. The rock won. So we know that this one is harder than my fingernail. Let's try this one. What do you think? Do you think this will be harder or softer than my fingernail? You think the rock? Yeah, I think the rock will probably win this one too. Let's try it. Yeah, as much as I try to scratch it, whoops, let's let the camera focus there. As much as I try to scratch it, I'm not really able to scratch anything off. So far, these have all been harder than my fingernail. Let me try just one more that I have with me here. I have this one. It sounds like those of you trying it at home, the rocks have won this time. Let's try one more. Do we think this one will win, or do we think that my fingernail will win? What do we think? There's kind of two different parts to this rock, and I'm going to test both of them. So when I try it over here, I'm not able to leave a scratch. That is pretty hard. How about over here? Ooh. Check this out, my friends. When I scratch over here, I notice that I get some of it on my fingernail. So when I scratch over in this area where the rock is almost chalky, it's almost like a chalk-like texture. This is called the cortex of this particular rock, this outside part. It's softer than my fingernail. So we would say that on the Mohs hardness scale, this part of this rock has a hardness of 1. This is a 1 on the Mohs hardness scale. Okay, let's test something else. We're gonna go up to something a little bit harder. We're gonna try a penny. So this is just a regular copper penny. The reason we use a penny is, of course, because they're made of copper. So we're not really testing it against the penny itself, just the material it's made out of. And I'm gonna try to see if I can leave a scratch on the surface of my rock. What do you all think? Do you think that the penny will win or that the rock will win? Maybe not. Maybe we think that the rock will win. Let's find out. Or we think maybe penny. Let's see. Let's see. All right. I'm going to scratch it to see if I can leave a scratch. Nope. When I look at it really closely, I actually see a little bit of residue that I think is maybe from the penny. And you all can see, if the camera will focus, maybe, hopefully. Let's see. You all may be able to see that there's a little bit of the penny that was actually scratched off, right? So the penny, or rather the rock won this one. So the rock won this one. Let's try this one. What do we think? I'm gonna try to scratch this one with the penny. Let's see if I can leave a scratch. Let's see. Yeah, when I scratch it, I don't see any scratches on here, but I do see my penny being scratched away here. So you know how new pennies are really shiny? They're really that shiny copper. And then as they get older, they get something called a patina or a patina that kind of turns it a darker brown. You can see where I've scratched off the top of that patina with this quartz rock. Another way we could do this, I've been scratching the rocks, but we could use the rock to try and scratch the penny. I'll see if I can do that. Oh yeah, check that out. This rock is definitely harder than this penny. So let's try this last one that we were using. This one here. So we know that this one will be softer than the penny, right? Yeah, I'm able to leave a pretty good scratch on that. But do we think that this part will be softer than a penny? Which one, rock or penny? What do you think? Let's test it out. We think penny? Let's try it. So I'm trying to leave a scratch here, and it does look like there's a streak, but I'm looking at it, and this is a metallic streak. This is something that was left by the penny. You can actually see where it scraped away. This is a different edge than the one we were using before. So you can see where it actually scraped away and even left a bit of penny on the rock. So these are all pretty hard. The next thing we could try is we could try a push pin, right? So we could try and see if this will leave a scratch. Push pins are made out of different kinds of metal. So depending on whether it is made out of tin or iron, it may or may not leave a scratch. So we say that the Mohs hardness level would be around, I think it's like a 4 to 7 if the push pin is able to scratch it. And I'm looking, and it looks like I'm able to scratch this rock with my push pin. Yeah, I'm definitely able to scratch this rock. Yeah, I'm looking at my push pin, and it's not that it's scraping my push pin, it is that it is scraping the rock. So this one is a Mohs hardness at about 4 to 7, we'll say. Let's do one more on hardness before we move to kind of our last testing criteria. I have a little bit of glass here. So I'm going to use the thick side of this glass, and I'm going to see which is harder, the rock or the glass. Now I could, of course, try and break the glass, but I'm not going to do that. What I'm going to do is I'm going to try to scratch the glass. You can see where I've tested before. It is possible for some rocks to scratch glass. I will definitely be very, very careful, Jenna. I'm going to take this rock and hold it like a pencil, and I'm going to gently rub it against the glass. Now, when I look at it, oops, there we go. It leaves a little bit of stuff behind, but it doesn't scratch the glass. I can easily wipe away where I have rubbed this rock against it. And that's because we know that this rock is softer than a push pin, so it would definitely be softer than glass. Let's try the quartz. Ooh, now this one looks like it's making a mark. I think that the rock is beating the glass. So you can see that on there, how it has left that scratch. Even when I try and wipe it away, it still leaves that scratch. So that means that this rock is harder than this glass. Yeah, there's a little, you can see like a little line right here. Your quartz did as well? Yeah, and it seems like you recognize this type of rock. This quartz is definitely a pretty hard rock. We've tested it against, let's see, we did fingernail, we did penny, we did thumbtack, we did glass. There's some other things we could test it against if you have something that's harder than glass. I know that if you were testing it in a laboratory, you would move all the way up to a diamond-tipped drill head, right? Because diamond is the hardest material that we have access to. I don't have one of those with me, but there's something else that we can test that I'm going to try and fit in before the end of our program here. We can test hardness, and we were leaving some scratches on things, but we can also test something called the streak. And the streak is the color that a rock leaves behind when you kind of grind it a little bit. So what we could do is pulverize a rock into powder and see what color the powder is. But I don't have anything to break a rock up, right? So what I'm going to do is I'm going to use some unglazed pottery. This is just a regular flower pot that I had around. And this unglazed pottery is something that's really good for testing streak. Not all rocks will leave a streak on this, but I'm going to see if I have any that do. So I'm going to try this rock, and I'm going to just kind of use it like a piece of chalk, like I'm drawing on it. And when I look at the streak that's left behind, it looks kind of white, looks kind of whitish grayish. And I know that that's not just a scratch that I'm making in the surface of the pot. It's something that I'm leaving behind with my rock. So I'm going to try that one. Here's one that I tried earlier that surprised me, the color that it left. So I have a little chunk of pyrite, also called fool's gold. And I was testing its streak earlier, and I was surprised at the color it left behind. What color do you think it will leave? What do you think? Do you think it will leave a white streak, a brown streak? Ooh, these are some good thoughts. Let's find out. Look at that. It leaves this really kind of dark grayish streak behind. So that surprised me. I thought maybe it would be a light color because I always think about it being very, very shiny and bright, but it leaves this kind of really dark color behind, almost like a pencil lead. And we can try different ones. We can try our quartz. I'm going to see what color the quartz will leave behind. That one kind of left a white streak behind. Mostly the quartz is so hard that it's kind of scratching my pot a little bit. Let's try one more that I have. Let's see. Ooh, what do you think? So here is a piece of amethyst, a beautiful piece of amethyst, which is a type of quartz. What color streak do you think that it will leave? What do you think? Maybe white, maybe purple. I mean, it is such a beautiful deep purple. I would think maybe purple. Let's find out. So it left a white streak, and that's really interesting because so did my white quartz. These are made out of the same material. They have the same hardness. The difference in their color just has to do with the way that it was kind of processed when it was inside of the earth. So amethysts are quartz that turn out purple because there are other minerals like iron oxides around them when they are being formed. Something like citrine that I have right here is the exact same material as all three of these. It's all quartz, but it was heated at a higher temperature. So citrine forms, maybe it starts off as kind of this purplish if it has those minerals present, but if the temperature is high enough, then it turns this kind of yellow color. And I have a lot of different rocks that I've kind of gotten through the years at different places. Some of them I have found on the ground. I'll show you one of my favorite things that I ever found while I was visiting the mountains is this lovely piece of, I believe this is some jasper, and it's really nice. So you never know, there's a lot of really cool rocks around us, and when we clean them up and take a look at them, a lot of times we're surprised by the cool things that we're able to find. This is another one that I found, and I really liked how it had some red veins in it. So we talked the visual things we can see. We talked about, like color and luster and transparency or opacity. We also talked about hardness. We talked about streak, what color streak it leaves behind. And there's one last one I want to do here at the very end. And that is a chemical test. So I have a chemical here that looks like water, but it's not water. This is just some white vinegar. You can use any kind of vinegar because vinegar has in it acetic acid. So when a geologist is testing rocks, they might use a stronger acid like a hydrochloric acid. I don't have any of that with me today, but I do have this pretty strong acetic acid. So I'm going to give this a try. I want to see if there's any kind of reaction when I combine this acetic acid with any of my rocks. What I have with me is something that itself is not a rock, but is made from rocks and minerals. It's a piece of chalk. So this is one that I like to start the vinegar test with because there's a really interesting reaction and it can kind of show us what to look for when we are testing our rocks with vinegar. So I'm going to put mine on this spoon and I'm going to drop it into the vinegar and see what happens. I'm going to kind of bring it out so that we can see it a little bit better. Let's see. Do you guys see a little bit of that bubbling going on? It's a little bit hard with this color to be able to see this bubbling. Let's see, let me try a different one. This one may be a little bit easier to see. I have a shell here, which is made out of minerals, though it itself is not a rock. We're gonna see if you can see this reaction a little bit better. Yeah, it's a little bit hard in the light here. Let's try it like that. So if we look really, really closely, there's a little bit of bubbling going on. And I can even hear it a little bit. There's a little bit of bubbling happening because there is a chemical reaction that's going on between this shell and the vinegar. Oh, that's a good way to be able to see it. Do y'all see my bubbles happening? There we go, that's the way to do it. So this is not just air escaping, this is a chemical reaction happening between the calcium in this shell and the acetic acid. So there are different kinds of rocks and minerals that will react with our vinegar. We could certainly try it on our different rocks that we have collected today and see if it has that same bubbling effect. Yeah, it's an acid-base reaction happening there. And it's actually turning the water cloudy because it's almost kind of dissolving the shell. That's a pretty cool one. In fact, if I left this shell in probably overnight, I know it would be a lot smaller the next day. That's kind of an interesting experiment to do if you're ever interested in testing out some of your seashells. I'm going to go ahead and bring the camera back to my face cam since we've been on experiment cam for a while, taking a look at all of the different ways that our rocks can be tested and classified. So we talked about, let's see, We talked about visual things that we can see, like the way it interacts with light, its color. We talked about how it's different if you put water on it sometimes. We talked about how you can test hardness with something as simple as your fingernail or a penny. You can also test streak, the color it leaves behind, and you can do different kinds of chemical tests, like using acetic acid to see if there is an acid-base reaction. So there's a lot of other properties of rocks. Some rocks have special properties, like I don't have any sulfur with me, but that's one that has a really funny smell. Some rocks are magnetic. They will react to a magnet. Some rocks have cool properties like their ability to fracture in predictable patterns. I have a piece of Georgetown flint with me here. And this is really cool because if you hit it at a certain place, it can flake off really well, really easily. I really like flints. So this has a very clear, it fractures really, really easily and really straight. It's not like crumbly when you hit it. This is one that I hit off earlier. I didn't want to do it on camera in case I accidentally sent some rock pieces flying. So we've talked a lot about a lot of different kinds of rocks. I'm sure that there's much more to be tested about your rocks. And I really appreciate you guys doing the experiment along with us today. Ooh, pumice would be a really good rock to test. I don't have any of that, but that would be a really good one to test. Very cool, my friends. Yeah, no, thank you all so much for checking out rocks with us today. I hope that you will test some of the rocks that you have found around your house or at a park near your house or wherever you find your rocks. We would love to hear about any interesting test results that you get. If you want to share those with us by tagging the museum and #LifeCone on social media. Regardless, we really, really enjoyed being able to test with you today. As always, we will send out the curriculum and materials list after the webinar, and this one will go up on YouTube a little bit later in the week. So thank you all so, so much for your awesome participation. I hope that you will continue to test some rocks. I've got some rocks all around me that I'm really excited to continue to test. All right, see you later, my friends. Thank you so much for joining us. I hope that we will see you next week, where we are going to have a very special behind-the-scenes tour of Carolina wildlife. So we're going to see some of the indoor animals and the animal care team hall. So that's a really exciting one. I hope that I will see you all there. See you later, my friends. We'll go ahead and end our webinar.